In a circular table cover of radius 32 centimeters, a design is formed having an equilateral triangle ABC in the middle as shown in the figure. Find the area of the design. Now, to find the area of the design, first let us find the area of this triangle ABC. So that is our first step, to find area of triangle ABC. Now, triangle ABC is an equilateral triangle, and if it is an equilateral triangle, that means all the angles are 60. Therefore, angle B will also be 60. Now, this is angle B, which is 60. Now, we take O as the center of the circle. O is center of, this is the circumcircle. Now, when we join OB, this OB will bisect the angle. OB bisects angle ABC, which means now that 60 we can write it as 30 and 30. So I join this up. This is, and here this is the bisector. This is the center. So now I can say this angle is 30. So next I will write angle OBC is equal to 30. This is the property of the equilateral triangle. Let us now focus on this triangle. On triangle, I'll put this as M. On triangle OMB, we know angle OBM equal to 30. We have written it here. OB is a hypotenuse and also the radius, which is equal to 32. They have given radius 32, so this is 32. Now BM is the base. So let me mark that. Here we have BM is the base and OB is the hypotenuse. So when hypotenuse and base is involved, we use cos. We put this as x. So we'll write with cos 30. Look up in the figure and see what is cos 30. Cos 30 will be BM, which is the base, over hypotenuse, which is OB. And this is equal to BM, we know is 30. BM we don't know, so that is x. And OB is 32. So cos 30 is equal to x by 32. And we know the value of cos 30 is root 3 by 2 is x by 32. So the x becomes 32 root 3 over 2. So x is 16 root 3. Let's mark the x in our figure. So this was our center. Here was, this was a triangle we considered. This was angle 30. This was 12. And here was M. So we have now found out that x, that this is 16 root 3. This is also 16 root 3, which means BC is equal to 16 root 3 plus 16 root 3. So BC is 32 root 3. Now when you take up the triangle, we already have found the side. So for the triangle ABC, which is equilateral, The side, all the sides are equal. We found the side is 32 root 3. Therefore, area of the triangle will be root 3 by 4 side square, which is root 3 by 4, and the side is 32 root 3 the whole square. We work this further, we get root 3 by 4, 32 into 32, root 3 is 3. So we cancel this, we get 8. So the area of this triangle comes at 768 root 3 centimeter square. So we have now found the area of this triangle as root 3 into 768 centimeter square. In our next step, we are going to find the area of the circle, and then we will subtract both the areas to get the area of the design. So area of circle, pi r square, pi 22 by 7. The r of the circle is already given to us, is 32 square. So area of the circle is 22528 over 7 centimeter square. In the next step, we are going to subtract both the areas. So area of design will be area of the circle minus the area of the equilateral triangle. So area of the circle we know is 22528 over 7, minus of equilateral triangle area is 768 root 3. So this is your answer. So this was, again, the design was area of circle minus the area of the triangle. What remained behind is this area of this design once you subtract it out. And to find the area of the triangle, we use trigonometry to find the side. In the figure, ABCD is a square of side 14 centimeters. With centers ABCD, 4 circles are drawn such that each circle touches externally 2 of the remaining 3 circles. Find the area of the shaded region. So when you look up at the figure, first we have a square. ABCD is a square, and the side of the square is given to us. So let us find the area of the square. So first step, area of square ABCD, which is equal to side square. So area of ABCD, the side is given as 14, so will be 14 into 14, which is 196 centimeter square. So that is the area of this entire square. So we found the area of the square. The next, we need to find the area of the sectors. So here we have 4 sectors, 1, 2, 3, and 4 sectors. And from the square, if we subtract these sectors, what will remain is the area of the shaded region. So in step 2, we need to find area of 4 sectors. Now area of one sector is theta by 360 pi r square. However, here we have 4 sectors, so 4 into. Now what is the theta in this case? If you look up in the figure, theta is the 90 because it was a part of the square. So the theta for each of the sector is 90. So this is 90. And what is the radius? We know this entire AB is 14, so they have given us the side as 14. Therefore, half of it will be 7. So 7 will be the radius of each of this. This will be 7. Here is 7. This is 7, each radius, 7, 7, 14. So we have radius equal to 7. So when we work this out, to get 4 into theta is 90, 360, pi 22 by 7 r 7 square. So this is area of the 4 sectors. And on cancelling, you will get 154, area of 4 sectors. Now the area of the shaded region, next we will find area of shaded region. If you look up, it will be area of this square. So the area of this square minus the area of these 4 sectors. These 4 regions. So area of this green. So this is area, this was square minus 4 sectors. So area of square we already found out as 196 and the 4 sectors was 154. So on subtracting 196 and 154 is 42 centimeter square. That's the area of this shaded region. It was a square minus the 4 sectors, minus the green. Figure 12.26 depicts a racing track whose left and right ends are semicircular. The distance between the 2 inner line segments is 60 meters. Let us mark that. So this distance, they said, is 60 meter. Like this distance here is 60 meter. They are 106 meter long. So this parallel side is 106. This parallel side is also 106 meter. If the track is 10 meter wide, so I think this was wrong. This was not 60. It was the distance between the track is, this is 60. This is 60. And it was 10 meter wide. So here this is 10 meter wide. The width is 10 meter. This width is 10 meter. It is 10 meter wide. Find the distance along the track, along its inner edge, and the area of the track. So first we'll find the area of the track. The area of the track is this entire blue area. This is the area of the track. This full thing. This blue area is the area. So let's go ahead and find the area. To find the area of the track, I'm going to divide the track into 4 figures. If you see, this part is a rectangle. Let me color this up. This entire thing is a rectangle. So we have A, B, C, D, one rectangle, P, Q, R, S, the other rectangle. Now the rectangle is length into breadth. It was given to us that this length is 106 meter and the breadth was given as 10 meter. So if we were to find the length of the rectangle, the length was given as 106 meter of this rectangle and the breadth is 10 meter. So if we want to find the area of ABCD, will be length into breadth, which is 106 into 10 and 1060 meter square. And the area of PQRS also is the same. The length is 106 meter and the breadth is 10 meter. So here again area of PQRS is length 106 into breadth 10, 1060 meter square. So we found these two areas. This is 1060 meter square, and this area also is 1060 meter square. Now next we are going to find the area of this portion. If you see, this portion is outer semicircle minus the inner semicircle. Yeah. And on this side also it is the outer semicircle minus the inner semicircle. If we subtract that, we will get this area of the two semicircles, the ends of the racing track. So now let's find the area of the outer semicircle. This is the outer semicircle. For the outer semicircle, we must know the outer radius. Right from here, this to the width is 30, because we know the hole is 60, so this is 30, and then this part from here to here was given to us as 10. So for this semicircle, the outer radius, which we write as capital R, is 30 plus 10, and that is 40. So outer area, this will be outer semicircle pi r square semicircle, so divide by 2. So that will be pi, your r you know is 40 square, divide by 2. So now we have found this outer semicircle. Now from this outer semicircle, we need to subtract the inner semicircle, this inner semicircle. Then we will get the remaining area, this inner. If you look at the inner semicircle, you already would have noticed that the radius is 30. So for inner semicircle, the inner radius is 30 meter, and the inner semicircle area of inner semicircle pi r square, the small r, over 2, because it is semicircle, so which is pi 30 square over 2. This is area of the inner semicircle. So when we do outer semicircle minus the inner semicircle, we will get the area of this green region, which means now when we want to find the area of 1, area of 1 will be outer semicircle, which is pi 40 square over 2, minus inner, that is pi 30 square over 2. Now you can take pi over 2 common out. What remains inside is 40 square minus 30 square. So this is the area of 1. So we put pi over 2, a square minus b square, a minus b, and a plus b. So we have 22 by 7, that is pi 1 by 2. This is 10 into 70. So you can cancel this out, you get 5, you can cancel this out, you get 10. So this is 22 into 50, which is 1100. That is area of 1. So we found this area of 1 is 1100. Now this area also will be identical to this. This is 2. This area also will be same. So this area will be 1100. Earlier we found out the area of this region, which was a rectangle. We found this area as 1060. Similarly, this area also was 1060, equal area. Now we can find the total area. So total area of the track equal to 1060 into 2. There were two of these areas, and 1100 into 2. We work this out to get 4320 meter square is the total area of the track. So just to recollect, this was a rectangle. So we did length into breadth. This was also a rectangle, and we did length into breadth. These other two areas were outer semicircle minus inner semicircle. For this one we did outer minus inner semicircle. Here also we did outer minus inner semicircle, and then we added up all the areas. The next we have to find the inner edge. So the inner edge is made up of this part here and this side. We'll call them, say, XY, and this is ZW, and it was given to us 106 and 106. So the inner area was XY plus ZW plus this semicircle, the semicircle here and this semicircle here, these two semicircles, plus semicircle XZ plus semicircle YW. So we add up, this is 106 plus 106, and you know semicircle formula is 2 pi r is full circle divide by 2. Here also 2 pi r full circle. Semicircle means divide by 2. So we have 106 plus 106 is 212, plus we cancel this out. So what remains here is pi r plus pi r. So this is now 212 plus pi r plus pi r is 2 pi r. So 212 plus 2, 22 by 7. Now what is the radius? The radius is this here. This is the radius, which we know is 30. So we write here into 30. So working this out, we get 212 plus is 1320 over 7. You take the LCM, you work it out, and you get 2804 over 7. Let me write it again. 2804 over 7 meter is the inner track, the length of the inner track. In the figure 12.27, AB and CD are two diameters of a circle with center O perpendicular to each other. This is important. OD is the diameter of the smallest circle. If OA is 7, find the area of the shaded region. So here they have given OA as 7. Let's mark OA. So this is OA is 7. So this is 7. This also will be 7. OC will be 7. OB will be 7. And OD will be 7. That is our first point. So we have OA equal to 7 centimeter. It is given. So I have OA equal to OB equal to OC equal to OD equal to 7 centimeter. These are radii of the same circle. Now first we will find out the area of this circle. We'll call it area 1. Let's find the area of 1. So here 1 is a circle. So area 1, it's a circle, hence formula pi r square. But what is the radius of this circle? This was 7 centimeters. OD, have you seen here? OD was 7 centimeters, which was the diameter. So OD is the diameter. So diameter 7 centimeter, radius 7 by 2. So area of 1 is pi, that is 22 by 7 r square, 7 by 2 into 7 by 2. So you cancel this becomes 11, and on multiplying you get 77 by 2 centimeter square. Next we need to find this area. We call it area 2. So to find area 2, it will be the area of the semicircle, this entire semicircle, minus the area of the triangle, area of this triangle, semicircle minus triangle. So area 2 is area of semicircle minus area of triangle. Let's get up to the triangle and see. Triangle, you know, is half base into height. So here is the base and this is the height. Because it is given to us, this angle is 90. So for area of triangle, I will put minus half the base. Base is AB and the height is, see, this is O, is OC. And that would be height. AB is 7 plus 7. This was 7 and this was 7. So AB is 7 plus 7, that is 14. And OC is also 7. So this is area of the triangle. Now to find the area of the semicircle. Full circle pi r square, semicircle means divide by 2. Now the radius of this semicircle, this is the radius, which is 7. So radius of the semicircle r is 7. So we put those values too. So that will be pi 22 by 7, r square 7 into 7 over 2. So area of semicircle minus area of triangle. So again we have to find the area, this area 2. And to find area 2, in the first step we have to find area of semicircle, this semicircle. So area of semicircle equal to area of circle pi r square divide by 2. So pi is 22 by 7. Now the r we know is, this is the r of the semicircle and that was 7. This was O here, so this was 7. So we put the values. 7 into 7 and divide by 2. So this would cut and this would be 11. So area of semicircle is 77 centimeter square. In the next step we have to find the area of the triangle, this triangle, and we need to subtract it later. So now we go ahead and find the area of this triangle. Next, area of triangle. Area of triangle, half base into height. Half. The base is AB. This is the base AB. And the height is OC. Now we know AB is 7 plus 7 because this is 7 and this is 7. So AB is 14 and OC is 7. So that will be, if you cut now this will be 49. So area of the triangle is 49 centimeters square. So area of the shaded part, that is area of 2, equal to area of semicircle, that is 77 minus 49, which is equal to 28 centimeter square. The area that we needed to find was this one, area 1. This was area 1. So area 1 plus this area, which we called area 2, plus area 2. Area 1 was 77 by 2, we found it earlier, and area 2 was 28. You add them up together, you get 66.5 centimeter square is your answer. Area of an equilateral triangle ABC is 17320.5 centimeters square. With each vertex of the triangle as center, a circle is drawn with a radius equal to half the length of the side of the triangle. Find the area of the shaded region. So first it is given to us that the area of the triangle, this triangle ABC, this triangle is, the area of this triangle is given, so let's work that out. Area is given as 17320.5, that's given to us, and it's an equilateral triangle. So if it is equilateral triangle, the formula for equilateral triangle is root 3 by 4 side square is 17320.5. So to remove the decimal, I'll do 17320.5 over 10. Now S square will be 17320.5 over 10 into 4 by root 3. So S square is 17320.5 over 10 into 4. Now root 3 is to be taken as 1.73205, which means S square is 17320.5 over 10 and into 4, but now I have to remove the decimal in the denominator, 7.3205, this decimal. This decimal, if I remove, I need to multiply on the top by 1, 2, 3, 4, 5. So I'll cancel this. Let me write it neater. So 17320.5 into 4, and this is 1, 2, 3, 4 over, because 1 0 reduces, 205. So this cancels out. So I have S square equal to 4, 1, 2, 3, 4. S is under root of 1, 2, 3, 4, and this is 200. So the side of this equilateral triangle is 200, which means now the radius is half of the side, this part will be 100, the radius of the circle. So let me write that part. So I have the side equal to 200 and radius equal to side divided by 2. So radius is 200 divided by 2. So radius equal to 100. So remember, the radius of this circles is 100 each. Now we know the radius is 100, so this is 100. If we want to find the area of this sector, and remember there are 3 such sectors. So this 3 areas, this is 2 and 3 sectors. So let's find area of 3 sectors. will be 3 into area of sector theta 360 pi r square. Now the theta here will be 60 degrees. Now why 60? Because it was an equilateral triangle. So we know theta is 60 because ABC are angles of equilateral triangle. The radius we already shown was 100 centimeter. Radius was S by 2, half of the side. So now the area of 3 sectors equal to 3 theta 60 360 pi r square, and the r is 100, so it is 100 square. Here they said the pi should be 3.14, so we cannot use 22 by 7. We have to use 3.14 into 100 square. So area of 3 sectors, you cancel this. 1s are, 6 are, 2s are, and when you work this out, you will get 15700. Now for the last part, we need to find the area of this region. The area of that will be area of this entire triangle ABC here, triangle ABC minus the 3 sectors. So area of shaded region equal to area of triangle minus area of 3 sectors. Now area of the triangle was given to us 17320.5. It was given to us, and the 3 sectors we found out now, 15700. So this area is 1620.5 centimeter square. This is area of the shaded region. Let's just summarize the sum. We started off with this area. So this area was given to us. Area of ABC was given to us. From this area, we use the formula √3/5 side square, and that area I think was given as 17320.5. By using this, we found the side. The side we found is 200. So this side was 200, this was 200, this was 200. Then in the next step, we found the radius. The radius was half of the side, so the radius was 100. This radius was 100. Here, this radius now, from here to this here to here was another 100. So the next step we found radius, which was 200 by 2, and that was 100. And then we found the sectors. For this sector we found all 3 sectors, 1 sector, 2 and 3 sectors. That was a third step, area of 3 sectors. That was 3 into theta 360 pi r square. And then we subtracted both the areas. We subtracted the area of the triangle to find the shaded region. This was the shaded region here. We did the area of triangle minus 3 sectors. So area, this triangle minus 3 sectors, these 3 sectors, 1, 2, 3 sectors, gave you the area of this shaded region.